This is an introduction to the Real Vibrations vibration shaker controller software. This system is currently connected to a single axis vertical vibration test system fitted with an accelerometer as a feedback sensor. What you see on the screen are the main parameters for a random vibration test. On the bottom left is the target PSD function. The system comes pre-programmed with a variety of target PSDs, and these can be selected here, as you can see, and they can easily be selected and changed. The RMS level, in this case the system is being configured for a constant RMS level, which will produce Gaussian random vibrations, and the RMS level can be set very easily and is shown here as a single level. In other cases, the system can be set up to synthesize or generate vibrations which are non-Gaussian and non-stationary by fluctuating the RMS level, and in such cases the RMS is defined as a distribution function. But here we will make this demonstration for a constant RMS test. In here on the top left of the screen, you will, as I showed you before, this is where you select the PSD function. Here we can select the RMS distribution, and here we can select the test duration. And this menu here contains the important parameters of a shaker, including the feedback sensor characteristics. We can also specify if we wish to apply a real-time digital filter to the feedback signal. This can be a band pass, low pass or high pass filter. And also here we set up the parameters for measuring the system frequency response function, which is needed to pre-compensate the drive signal when we undertake a random test. The other parameters are explained in detail in the software documentation, but once these are set, these rarely have to be changed. And this shaker ID identification module, or shaker ID, needs to be performed occasionally to make sure that the dynamic properties or dynamic characteristics of a shaker are updated to obtain an accurate test. The system comes built in with a series of add-on functions such as shock on random or transient on random, sign on random or sign sweep on random. For these there will be separate demonstration videos available on our web page. Also, the system has a feature to capture the feedback signal, that is to record it gap-free to disk, and also it enables us to capture auxiliary channels which are available in the hardware module that comes with the system. You can set the number of channels you want to capture, the units and the sensitivity of all the channels or the sensitivity of individual channels, and these are recorded in format suitable for analysis or display by MATLAB. And now all that is left to do is to start the test by pressing the start button. The signal is generated, and what you see on the middle of the screen on the top is the feedback signal, that is the vibration levels or acceleration that are being produced on the shaker. Bottom left you can see the average power spectral density function in blue against the red of the target function. We can also control the display to include some plus or minus 3 dB tolerance, and we can also plot the instantaneous PSD, which is shown in gray. And that keeps track of the PSD achieved during the test. Top right, we can also display the probability density function of the generated signal, which here, because this is a constant RMS signal, we can see conforms to the Gaussian distribution. The system also has a facility to pause, so we can actually pause a random test if we wish to adjust something or undertake inspection of the object under test, and we can resume the test once we're done, and that will resume the counter. Also here there's a fair bit of information coming back. We are also given the number of spectral averages of the overall RMS level that is achieved. And once the test is completed, it will stop automatically, or we can prematurely stop the test. And I hope you found this demonstration useful. There are many other video demonstrations on our webpage, and you are most welcome to have a look at them or get in touch with us for more information. Thank you.